I have given you your first two reviews for the AP exam, but at this point we kind of need to go through this, and I need to actually walk you through a practice one, also, as well as talk to you about one of the fundamental theorems of calculus and how the College Board really likes to have it show up in the AP exam all over the place. I mentioned this briefly earlier in the year, but that's been a while now. So here's the fundamental theorem of calculus that they really like to have show up a lot. It's the one for definite integrals. So if we have the definite integral from a to b of f of x dx, it's equal to big F of b minus big F of a, where big F is an antiderivative of f. Okay. So think of it like an equation, and so if we add the big F of a to the other side, then big F of b is equal to big F of a plus the definite integral from a to b of f of x dx. And the way you got to think about it is it's the ending amount is equal to the initial amount plus the accumulation from a to b. Okay, and so I'm going to do an example FRQ. It's similar to one of the ones that I sent out to you guys. By the way, I know that it said set your timer for 25 minutes on those two problems. I don't expect you to necessarily get those two problems done within 25 minutes because they're the first ones that we've ever done. That's something that we are working our way toward. Anyway, here's an example given a graph, and don't forget, anytime we are given a graph, you always have to identify what type of graph it is first. And so it says this is the graph of y equals f prime of x, so it's a derivative graph. And then they also give us some words, so make sure you read the words. Graph of f prime is a continuous function with domain from -6 to 3. It's made up of a semicircle, you can see that out to the left, and two line segments. And also f of 0 is equal to 7. Okay, part A, identify all relative min-max on the open interval from -6 to 4. Explain why. Find all points of inflection on the open interval from -6 to 4. Explain why. And part C, find the absolute min and max of for the function f of x on the closed interval from -6 to 4. Okay, so part A. Now, the fact that they've given us a graph of the derivative, and I like to get it into number line form myself. I think it's a lot easier to see. Where is f prime equal to 0 on the open interval from -6 to 3? Well, it's equal to 0 at -2 and also at 1. So number line, make sure you label it f prime. It means nothing unless you actually label it. So we had two places where it was equal to 0. So we had at -2 and +1, and that's where it was equal to 0. And to the left of -2, the derivative was below the x-axis, so it's negative. Then it's above the x-axis between -2 and 1, and then it's below again. So below, f prime is negative, above, it's positive, and below, it's negative. Okay? And so that tells us that we have a relative minimum at x equals -2, since it's a critical point and it goes from negative to positive, and we have a relative maximum at 1, so because it goes from positive to negative. Okay, now it's nice to have the number line, but that is not an explanation that they would accept on the AP exam. It must be a sentence. Okay, so let's write it out here. F has a relative minimum at x equals equals -2 because, or since x equals -2 is a critical point, and it's not enough to just be a critical point, and f prime goes from negative to positive on either side of x equals -2. Okay, so you need all of that. Okay. Let's do the relative maximum now, which should be almost the same. So f as a relative maximum at x equals 1, since x equals 1 is a critical point, and f prime goes from positive to negative on either side. Okay, so there's relative min, relative maximum. With the explanation. Find all points of inflection. Okay, so part B. Now, since this is the graph of the derivative, to be able to get to the second derivative where we can identify points of inflection, you have to be thinking of slopes of tangent lines. So if you're thinking of slopes of tangent lines, out here from -6 to -4, we've got negative slopes of tangent lines. And then at -4, you've got a 0 slope. And then you've got positive slopes until x equals -2, and then you still have positive slopes until x equals 0. I know there's a little place where it's not a smooth curve right there, so the second derivative would not exist at -2, but it's still positive slope all the way till x equals 0, and then from x equals 0 to x equals 3, it's all negative slope. And again, myself, I like to go ahead and put that into a number line. It's not necessary to do it as a number line, but I think it's a good idea just to get it down into something really easy to understand. So f double prime, labeling the number line. So I've got -4, I've got -2. And I've got 0, and at -4 the second derivative was 0, and -2 does not exist because it had that little corner right there, so the slopes are not approaching each other right there at that corner. So and then at 0 it does not exist again. Okay, visualizing the slopes to the left of -4, we have negative slopes. To the right of -4, you got positive slopes. So negative slopes, and you also have positive slopes between -2 and 0. And then to the right of 0, we had negative slopes again. Okay, so now it's not enough to be, and they're technically not critical points with the second derivative, but at the potential points of inflection, it's not enough to be just 0 or does not exist. Remember, you also have to have a change of sign. So we do have a point of inflection here at -4. There's not one here at -2 because there's no change of signs. And then we have another point of inflection here at 0 because there's a change of signs. Now, unlike absolute max min, it doesn't really matter what the change of signs is, whether it's negative to positive or positive to negative. If there's a change in signs, there will be a point of inflection. Also, just kind of looking ahead, it really didn't ask about this, but remember where the second derivative is negative, you got concave down. Where the second derivative is positive, you got concave up, and concave down. Because that sort of thing is asked about sometimes as well. And you could identify the intervals where things are happening. Okay, but answering the question here for part B, and the number line is nice, but it is not our justification, it is not our explanation. And so, let's go ahead and get that written down now. Sorry, moved it around. There are 2 points of inflection. On the open interval from -6 to 3. They are at x equals -4 and x equals 0 since f double prime of -4 equals 0, f double prime of 0 does not exist, and there is a change in signs for f double prime on either side of these x values. Okay, so that takes care of part B. Okay, so doing part C now, find the absolute min and the absolute max for y equals f of x on the open, or excuse me, from the closed interval. And I just realized I do not have my intervals correct for any of these problems. So, should not be from -6 to 4. Should be from -6 to 3. Sorry about that. Okay, finally doing part C, the absolute min and max on the closed interval from -6 to 3. Now remember, anytime you're doing an absolute min or max, the closed interval, it has to be a closed interval. Otherwise, you're not guaranteed to have an absolute min or an absolute maximum. So we need to check the endpoints. We also need to check any relative extrema that are also in that interval. Both our relative min and our relative maximum are inside of that interval. Doesn't really matter which ones you check first. Just make it orderly and show what's going on. I think I'll check the relative extrema first. So I'll advertise what's going on here. And so we had relative minimum at -2 and a relative maximum at +1. So x equals -2. Okay, now we need to pull in the fact that we already know that f of 0 is 7. So I'm going to do a definite interval from 0 to -2, because we're trying to find out what f of -2 is, for f prime of x. And if we integrate f prime, we get f, so f of 2 minus f of 0. Okay, so if we add f of 0 to the other side, we get the fact that f of 2 is equal to f of 0 plus that definite integral from 0 to negative 2 of f prime of x dx. Of course, f of 0 is 7. Okay, now, we don't know what f prime of x is, but we do have a graph, and remember that when we're doing integrating, what we're really doing is we're looking at area captured between the curve and the x-axis. So if we look at that, look, we have geometric shape, we have a triangle, we could calculate the area of that. Now, we are going from right to left because we're doing the definite integral from 0 to negative 2. Now, when we go from right to left, that is in negative direction, and so keep that in mind. I think it's not a bad idea to be very formal, and notice, it's like the bigger values on the bottom here of the definite integral and the smaller values up top. So we could use properties and switch them, and if we switch them, of course, we know that it becomes negative out in front. Okay, so we have 7 minus, okay, now from negative 2 to 0, again, it was that triangle. And triangle is just simply 1/2 base times height, so 1/2 the base is 2, the height is 2, and so really we have 7 minus 2, which is 5. Okay, so that is f of 2. f of 2 is 5. Now we have to check, there's 4 different things to check. We have to check the other extrema. We also had x equals x equals 1 was another extrema. Okay, so 0 to 1 of f prime of x dx. That's going to be f of 1 minus f of 0. Now this time I'm going from 0 to 1, so I'm going from left to right, so that's nice. F of 1 is equal to f of 0 plus 0 to 1 f prime of x dx. And so that's equal to 7 plus, okay, what's happening with the graph up here? From 0 to 1, it's another triangle. My base is 1, my height is 2. Okay, so 1/2 base of 1, height of 2. So it's 7 plus 1, which is 8. Okay, so f of 1 is 8. F of, sorry, I just realized I left off a negative. F of negative 2. F of negative 2 is, because I left off the negative right there, f of negative 2 is equal to 5. F of 1 is equal to 8. So at the moment, our absolute minimum is 5 as far as we can tell, and our absolute maximum is 8. But we also have to check the endpoints. Okay, so checking the endpoints. So we've got x equals negative 6. So now, we know what f equals negative 2 is. We could go from negative 2 to negative 6. I'm just going to go ahead and go from 0 to negative 6. Okay, so that's equal to f of negative 6 minus f of 0. So f of negative 6 is equal to f of 0 plus the definite integral from 0 to negative 6 of f prime of x dx, which is 7 plus that definite integral. Oh, but remember, 0 to negative 6. Might be kind of nice to do negative 6 to 0, which means that instead of plus, it's actually minus. So f of negative 6 is equal to 7 minus, okay, now from negative 6 to 0. So from negative 6 to 0, well, negative 6 to negative 2, I have a semicircle that's below the x-axis. That would be giving me, since I'm going from left to right now, that would be giving me a negative 1/2 pi r squared, negative 1/2 pi times 2 squared. So negative 1/2 pi times 2 squared. Okay, and then the other part that we have, since we're going from left to right, I've got a triangle, so positive 1/2 base times height, 2 times 2, so plus 1/2, 2 times 2. So this becomes 7 minus, okay, so we've got negative 2 pi plus 2, and if I distribute the negative, we get 7 plus 2 pi minus 2, which is 5 plus 2 pi. Okay, keep in mind that that's approximately about 11.28, just real general. Okay, last one, the other endpoint, x equals 3. Okay, now I can go from 0 to 3, or I could even go from 1 to 3, because we already calculated f of 1. You know, either way. I'm going to go ahead and start from 0. It works just going from 1, since we already know what f of 1 is. But you have to go work with something that you already know. I'm going to go ahead and go from 0 to 3. F prime of x dx is equal to f of 3 minus f of 0. So f of 3 is f of 0 plus definite integral 0 to 3 f prime of x dx, which is, okay, so 7 plus, okay, now the 0 to 3, we've got some of the graph that's above, and we've got some of the graph that's below. So I got to break it up into the 0 to 1 part, and it's the area of that triangle right there, so 1/2 base times height, 1/2 base times height. Now, if you want to just not mess with it, it's minus because it's below the x-axis, or you could say it's 1/2. The base is 2 because it's going from left to right, so the base is a positive direction, but the height is negative 4. So whether you just make it a minus right here instead and not worry about it and just do the 1/2 times 2 times 4, either way. And so we have 7 plus 1 and what is that, minus 4, which is 4. Okay, now we've calculated all these values, and so all we're doing is we're looking for which one's the biggest and which one's the smallest. So 4 appears to be the smallest. So here is my absolute minimum on negative 6 less than or equal to x less than or equal to 3 at x equals 3. And the 5 plus 2 pi is the largest absolute max on negative 6 to 3 at x equals negative 6. Okay, so 5 plus 2 pi is the absolute maximum. It occurs at x equals negative 6. And positive 4 is the absolute minimum, and it occurs at x equals 3.